Okay, so for part A, we're asked to draw a free body diagram. So FG is going downward, FN is perpendicular to the surface, and since it's going in a circle, acceleration will be going inward and it'll be labeled AC. So for part B, if we draw the cone here, right, FG is going downward, and it's on the y-axis, so it doesn't technically have components, but it is still exerting a force that is opposite to FN, which is this one. And since we know this angle, we know this one. So we could just set Fn as equal to Fg over sine theta, or mg over sine theta. I'm going to rewrite that so I can box my answer. We can also do it in the net force in the x direction way, which is also just Fn x, because there's no friction and gravity is not pulling in an x direction. So this expands to Fn cosine theta. We also know that the net force in the x direction is equal to Fc, which expands to mv squared over r. But since we're not given r, we can use the angles to expand r to h tangent theta. So these two are equal to each other. And then I'm going to expand this tangent into sine theta over cosine theta, because we can just bring that up. Fn cosine equals mv squared for h sine, and then cosine would go to the top, meaning we can cancel those two out. And we get this formula. Okay. For part C, we had to derive an expression using Fc. So Fc is equal to Fnx, as we dictated earlier, because they're both representative of the net force in the x direction. So we can use this formula that we already derived for Fn. So mg over sine times cosine, or this simplifies to just mg times cotangent theta. So I'm going to rewrite it so I can box my answer. For part D, we have Fc now, which is mg cotangent theta, but we also know that Fc equals mv squared over r, or mv squared over h tangent. And then we can set those as equal to each other. And then here m will cancel out, and we want to solve for v, so we bring this up. But then cotangent is just 1 over tangent. So these tangents will cancel out. And then we can square root both sides to get our final equation for v. So for part E, I'm going to solve it in the x and the y direction. Okay, so they give us a scenario where we have to solve for v max. And in this case, the box is moving so fast that friction needs to keep it on the slope so that it doesn't fly off. So Fx would be pointing this way. And then we can just draw the components. If we know this angle, we know this angle. And then Fn has components as well. So we can start off in the net force in the x direction. We can expand this to Fnx. And then Fnx is going towards the center. And we see that Fsx is also going to the center. So we can add them. And net force in the x direction is also equal to Fc, which is mv squared over r. And then what we can do is set them as equal to each other. And then expand this into Fn cosine theta plus Fn mu s sine theta. Then we can take out Fm. And then I can multiply this, or divide this, to isolate for Fn. Okay, and in the y direction, net force in the y direction has to be equal to 0 because the problem says that the car is not slipping. Fy is also equal to Fn y, which is, we see is going upward, but Fsy is going downward, so they would be opposing each other. And then there's also an Fg that's going downward. So we can set those as equal to each other. And then expand this to Fn sine theta minus Fn mu s cosine. And then add Fg to the other side. And then I can take out the Fn. And then expand Fg into mg. And then divide this over to solve for Fn. Okay, since these are both equations for Fn, we can set those as equal to each other. And then m cancels out, and we want to solve for v. So we can multiply this term up. And then we can square root both sides. And label this as V max. Okay, so for part F, we're going to take a very similar approach, except this time we're solving for V min, which means that the box is going so slow that it might slip down. So Fs has to be pointing this way. Okay, so now that we have all our components labeled, we can go ahead and split this off into the x and the y direction, like we did before. Net force in the x direction is Fc. It's also mv squared over r. And then net force in the x direction is also Fnx. And that's going towards the center. And Fsx is going away from the center, so they're opposing each other. And then we can set those as equal to each other. And we can expand this to Fn cosine minus Fn mu sine. And then we can take out the Fn. And then divide this over to isolate for Fn. Net force in the y direction has to be equal to 0 because the problem says that the car is not slipping. We also have fny, which is going upward. And then fsy is also going upward. And then fg is going downward. So we can set those as equal to each other. And then expand this. And then add fg to the other side. And then I'm going to take out the fm. And then expand fg into mg. And then I'm going to divide this over. Okay, now that we have both equations for fn, we can set them as equal to each other. These m's will cancel out, and we're trying to isolate for v, so we can just multiply this whole thing up. And then we can square root both sides. And this is v min. Okay, so for part G, for this equation to be true, friction actually has to be going downward. So friction has to be going this way to keep the box on the slope. So I'm just going to draw out all my components for all the forces. So what we're going to do first is solve for Fn. So in the net force in the y direction, it's equal to 0. And we can also expand it to Fny, which is facing upward, and then minus Fsy, because it's facing downward, and then minus Fg. And then we can set these as equal to each other. And then I'm going to bring it down here and expand Fny to Fn sine, Fsy to Fn mu s times cosine. And then I'm going to add Fg to the other side. And then I can take out Fn here. And expand Fg into Mg. And then we're going to isolate for Fn by dividing this. Now we know that because the net force in the y direction is equal to 0, the net force is just equal to the net force in the x direction. And then we can do Fnx, and then that's going towards the center, and Fsx is also going towards the center. And then we can just expand this. And then I can take out the Fn. And then because we don't know Fn and we just solve for it right here, we can plug that in. And then now we can rearrange the terms. And then the thing is, this is the correct answer, but it's not totally simplified. So what we can do is we can multiply everything in the parentheses by 1 over sine. That would give us and then we can simplify those terms. So cosine over sine is cotangent. The sines cancel out, so this is left as mu. And then sines cancel out, so that's left as 1. And then cosine over sine is cotangent.